Alright, so this is the second recording today. Still tired, all those things. It's going to be a little long. Please stick around. Please like. Please subscribe. Please do these things. It helps me out tremendously in being found and seen on YouTube. It's a very big deal, actually. Please watch all the way to the end. That also helps out a lot. Viewer engagement means that may actually recommend me to someone. Alright, now, this is a waste heat generator radiator concept that I have upgraded to being more efficient and better to manufacture and has less wasted heat to electricity made as a concept. Okay? Now, you need to look up the Jules Thompson cycle for a given way of exchanging cold or heat, in this instance, into surrounding gases. But it's the same gas. But in this case, we're talking about liquid. Alright? So, it's a version of a condenser, but then it uses the correct piping and inward piping with the correct slots for stators to produce with the right size and length. Wait for this. With a diaphragmic, kind of like a Stirling engine. Right? If not a Stirling engine, I like to call it just an air spring. It's a low pressure air spring. So, we're going to have piezoelectrics in this diaphragm. The tube happens to have from wider to smaller and then back to smaller still, with these areas for these stators, which are in between the tubes, which allow for airflow to go from the wider to smaller. And so what that does is it means instead of a capillary, it's the right amount of spacing and the right amount of these stators to create an acoustic pump. And Jules Thompson liquid to air heat exchanger. Now, during the heat exchange, it produces, you guessed it, a degree of expansion and contraction. Right? Just naturally, with the already made out of this composite piezoelectric and aluminum with insulative, leads with either copper or some other type of conductive material. I happen to use ceramic. Conductive ceramic does work and exist. It's also often thermally conductive, which is just fine, but that's just a separate non-thermally or electrically conductive. So it's like you have the standard electrically conductive, thermally conductive, and then the non-electrically conductive, but thermally conductive ceramic, which happens to have the insulative low pressure or very high pressure, depends on your design. I actually just use natural atmospheric pressure because I have holes where that is, to allow for the diaphragm to compress like a regular Stirling engine. There's a lower pressure and a higher pressure, and the heat does the rest. And that vibrates, of course, at certain resonant frequencies and acts as a pump, which is captured mechanical stress from the heating and cooling into the piezoelectric electricity. Alright? Now, that electricity is also on the tubes, which is outside to inside, which then dumps off into a reservoir next to it, which you have multiples of these outside to inside and then reservoirs that dump down. Now, it all depends on the size and the heat that you believe you will be trying to lose. Now, this creates static pressure that you have to go through, but these are all things that can be made by the correct geometric shaping, meaning the tube at the outside, you're thinking it has too many curves. You need to put holes where those curves exist. And then you need to have lines for the stators that go through that. And so it looks like from direct on, vertical, regular sized and spacing radiator heatsink fins. But to it doesn't. It's a larger diameter to a smaller diameter to a smaller diameter, which means larger volume to smaller volume to smaller volume, and it allows for some of that flow to restrict it to go through where the diaphragm area is for those stators, and some of it to not, which creates, as it flows through, a given heat pump that takes that acoustic vibrations of this liquid and then dumps the heat more outside versus towards the center. But it also happens to create mechanical stress and strain given the fluidic pressure changes, given the heat changes, and the cooling changes from the engine that is running this. This is designed specifically to run with car, motorcycle, and truck and plane or whatever types of engines that you can put this into, to take that, and with the thermoacoustic, which is automatic, we're not using anything other than the pump itself, and the thermals, which is thermal acoustic pump, using the Jules Thompson cycle to, as it condenses, but then because it's expanded, because that's coolant, even if it isn't a vapor, it still expands. Even if you think it's under enough pressure to not, it does. So that means you get a Jules Thompson heat exchanger. Usually Jules Thompson goes from a small, highly pressurized to then a larger, lower pressurized into an even larger, even lower pressurized system. Well, this is a pressurized but larger to a less pressurized then but smaller, and now to a less pressurized but even smaller still setup, versus you can't even play with those pressures, where it's like you can do a larger setup that's at a certain pressure, but then we're going to maintain that pressure or we're going to lower it. It all depends on the thermoacoustic pump. So it's like that will automatically, depending on the pump of these stators, because that allows for the thermoacoustic, and it opens and closes based upon that diaphragm there, that allows for that work energy that's already been captured to then also provide a valve and clearance change to better ultimately resonate and harmonically allow for the pumping, the thermoacoustic pump, to concentrate heat into those fins, and then also help concentrate cooling into the fluid flow, while allowing for the piezoelectrics and the diaphragm moving, which you can put a coil around there and have a little bit of magnet in that area, alright, and create even greater amounts of waste heat generated into electricity instead of work energy. Now, electricity can then be series and paralleled with some field effects, which is great, into a given battery and capacitor bank for these now high current, and then also the spark from a alternator, which is what I just put out earlier, or I'm currently uploading it as we speak. Turned into a video for the car upgrades. Well, this was the waste heat generator radiator concept, but now it's better, much better. Before, it used to have a phase change utilizing a lower pressure, 3 different freaking gases with a regular fluid that's dense fluid, and a whole bunch of linear generators, which was doable. And while it can even work on the mini instead of micro or even nanoscale, it wasn't very efficient. At most, any of that is 40% efficient for any linear generation, even if it's oscillating side to side for the pressure from steam, from the expansion of the fluids and the compression for, anyways, which is a thermosiphon, which takes a certain degree of that pressure, turns it into electrical energy, but the rest of it needs to be used to make enough pressure to then continue the cycle. Well, this no longer needs to do that. It's all in one. Piezoelectrics are far more efficient. They're 90% efficient for heat or not heat, but mechanical stress and strain to electricity conversion. And when you have a lot of them, and you put them in series and parallels with the correct composite of these materials, which is basic aluminum, and the correct, insulation of ceramic and all that, you gain with by the way, much less restrictive and a much greater amount of cooling capacity Jules Thompson heat exchanger cycle. You gain a greater degree of efficiency for the amount of energy that you have to put in. Thus, meaning 90% for all of the fins and the, of course, heat exchanger of heat to electricity conversion for the piezoelectrics. Now, the reason why I use the thermoacoustic pump and the Jules Thompson is because it makes that heating and cooling stress strain far, far more efficient again. Making it so if I put it in the proper series and parallels as a rail and reservoirs go through, then I gain even greater efficiency still, making it such that the piezoelectrics are probably closer to that 90% of heat to electricity conversion of this waste heat that I would have needed to have cooled down anyways for car engines and the like into electricity. Now, the caveat, of course, is that you need a pump to run it. Right, and so since you already are running a pump off of either electricity or the engine's water coolant pump, engine coolant, this will still ultimately help with that. Either manage, because we're talking about the heat here, not the amount of energy to pump it in, we might be able to literally fully reduce all parasitic loss and have a then some from the engine coolant, depending on how efficient we can make this for the thermoacoustic pump and the piezoelectrics, diaphragms, all this stuff for how it's manufactured in series. You gotta do a lot. That's another caveat. It's not been made before. Never been made before. At 90% efficiency for waste heat. Again, it's unlikely to get there because, of course, each individual line, of conductive ceramic, or plastic, or whatever it is that's ultimately used, that has a certain degree of resistance, and so I usually turn that into a capacitor for that electromagnetic, field that it typically creates, and then I turn that into a capacitor dump, meaning it stores it into a field, so it grabs that field, and then it stores that into capacitive style, like a capacitor, which then dumps it in a phase pulse. And so it'll build it up, dump it, and then to a series of parallels, so I get like what is essentially a three-phase with a regular DC, which then combines the DC with the three-phase, which then gives it a very high voltage DC look to whatever it is that it's going to go into, which is much more efficient. But then, because are in banks of series and parallels, all of those high voltage DCs are then turned into high voltage DC three-phase, which, when properly phased, will destructively, okay, cancel out any interference and make it much more smoothed out for the rectifying automatically of the given electricity going through, and also potentiates its outright amplitude, amperage, current, voltage for its given design, and it still has to arrive, okay, to the singular point that this goes to, which is the dangerous part, but that's also why that's so very efficient. So, like, that's larger efficiencies. Now, granted, I'm collecting like a 10% loss, but then when you have a 10% loss over like a large amount of this, then you gain a much higher amount of voltage, because we want it to turn just into voltage as the capacitor, right? As it dumps in the right phasing and pulsing. So it's like it has a certain wave with the pulse, which gives it like a 3-phase, which will then constructively interfere into a DC that's been paralleled and series into, with all of those parallels in series, a higher, like it's high voltage, but then all of those parallels in series because they're banks of this in the generator, right? Because you have to have the reservoir at the top, and then it goes from down, and then over, and then back down into the reservoir altogether. Well, think the same for the piezoelectrics. Piezoelectrics creates a DC in series, which are across the banks, and then parallel. Series down, parallel across. Same thing with the captured capacitor style of electromagnetic interference regenerator. So I'm going to take that, what used to be a loss, and turn it into a capacitor pulsar and DC current voltage changer. So it's like that's a capacitor that sends it into a high voltage as DC, pulsing it with a bunch of series out of phase, thus making a high voltage DC out of phase, 3-phase, that joins in through the DC, which then creates a DC high voltage, because it acts like it's a bunch of volts because of the pulse, and that constructively interferes to create what is known as a high volt DC. Then I have all of those in banks. For like no phasers. There's no in there. There was no in there. Yeah, but that makes it such that I have, if it's 3 banks, but it's likely to be more. And so it's like you divide that, and then you get a 3-phase AC, but it's not. It's 3-phase DC, or however many phases of DC that are all high voltage, that then destructively interfere with the interference between each other, separating them, acting like an AC that's now high voltage AC 3-phase, but it's all high voltage DC AC hybridization of the electricity going through with because of the interference, for electromagnetic fields. Well, the electromagnetic fields then get dumped into this, making it the lead, the gauge of wire here, turn into its own version of a capacitor dump interferer, constructive interference, destructive interference. It destroys the electromagnetic field and turns it into more electrons, creating, you guessed it, a very high full voltage AC-DC line that's rectified, but then it's like you still have to transform that into something your battery won't explode from. Same thing with all the rest of that. So it's like, right, and so that goes into whatever it is that you need it to go into to rectify it and transform it back into proper voltage and the proper amperage of the proper current that you're looking for the plasma generator and the spark which are in the previous video to this, which is called the car concept spark, let's see, valve spark and crank upgrades. Alright, I'll try and link it in the description. I don't know anything about annotations, I have never used them, so there's that, so you have to search it, but this one will come literally right after that one, so you should be able to find it just fine, and it'll be in the same playlist of creative ideas. Alright, this should be the end of it. That is now the waste heat generator radiator concept. Very, very, very put together and well done here. I talked about it back when I was in the Chandler house my parents had, back when I was around 25 to 28, somewhere around there. Years old, I'm 31 now. There's that. So, as a result, I never put it out. I just didn't think it was anything that was actually doable. Turns out, now that I know a lot more, oh yeah, no, very doable. I didn't know what this Jules Thompson cycle was at the time. I just called it out to in to out, or out to in, or in to out cycles. But apparently some other dude in the 1800s came up with it. So there's that. Moving on. Please like, please subscribe, please follow on my other accounts, also named Xenon Reality, and then there's Xenon Reality Color, and Gray Life, although that's my personal, I don't really upload anything to it, so there's that. Please, it helps me out with the algorithm. Sign up for notifications if you want to. Please subscribe, all that stuff. Have a wonderful day. Bye.